Away. Cool. For this video, we are of course doing the exam question, right? Yeah, let's get started. Sorry. So you have your diagram. They told you all the points, and that your corners, all these corners, they make up a parallelogram. We have it there, right? Then they say calculate the gradient of what? The gradient of dA. So here's dA, right? Where's EFF? All right, here's dA, and we're going to find the gradient of dA. You know for sure that the gradient m of let me just say AD, it will be y. Okay, let me say it will be y of A minus y of D divided by x of A minus x of D, right? So YA, here's A, 4. So we have 4 minus, this is y of course, minus 0. We have 4 minus 6, right? So you have 4, and then it's 4 plus 6. You have 4 over 10, right? Which is, when you divide by 2, that'll be 2 over 5, right? And the answer, it makes sense. Yeah, well, something I didn't say that is when you have a positive gradient, you know that there's an increasing. Okay, your function is or the straight line is an increasing straight line. As the values of x increases, the values of y does increase. You can even compare for these 2 points, D and A. So as we increase the number of the value of x, now we're increasing the value of x, the value of y also increase on this line. So yeah, so you have your 2 marks there. And then they say determine the equations of a line. Oh my word, okay. Oh my god. Okay, I'm realizing that I missed a chapter, or not necessarily a chapter, but I missed something. That there's something I didn't do. Yeah, so that's why I'm seeing this question and I'm like, yeah, but let's do it. So basically this is okay. Here, determine the equation of BC. Here's BC, which is parallel to AD, right? So since we know that gradient of BC equals to gradient of AD equals to 2 over 5, right? And what's your reason for that, right? BC is parallel to AD. Yeah. So now you know for your function you have y equals to mx plus c, right? You know your m, so I'm gonna do this for m. What value do we have? 2 over 5. And then we're going to find c plus c. We don't know what c is, so we're gonna look for any point that we have on BC, right? Oh, so we don't have c, let's use b. Y is minus 1, and then x is 2. So I have minus 1, I have 2, right? So yeah, all of this I'm gonna have to transpose to that side. So I have negative 5 over 5. I'm seeing this denominator 5, and then here I'm gonna have minus 4 over 5, because this is positive. We transpose to that side, it becomes negative, and this whole thing is gonna be minus 9 over 5 at minus 9 over 5. Yes, minus 9 over 5 yeah, which is equals to c, right? Which is equals to c. So now I just want to confirm these values. Say if I used 4 over 10, then 10 over 10, then 8, then wait. So yeah, we're good. You will then say therefore y of BC equals to 2 over 5x minus 9 over 5, right? Then they say determine the coordinates of A, which is the midpoint of line DB, right? You're finding the what? You're finding the midpoint, which is a 6 0. We have 2 minus 1. Cut. I need these points right here. Paste. So we are finding the midpoint, né? So you know, of course, the midpoint, it says E x y is going to be 2 minus 6 divided by 2, 0 minus 1 divided by 2, which is going to be, we have minus 4 here, so therefore we have minus 2, and then we have minus 1 over 2, right? These are your coordinates, minus 2, minus 1 over 2. And it makes sense because both x and y, they are negative. Right. So one thing I said, remember also with parallelograms, you know, this and this that are same. So because we have this, right, and this point, we can actually find this. And also since we have the equation here, yeah, I'm guessing maybe the next question they're gonna say let's find these coordinates, because also I was gonna say since we have the equation of BC, we can use that equation to find these points, but we don't have any other point here. Let's see exactly, see what I said. They say find the coordinates of C, right? Find the coordinates of C. So we have our midpoint here, and we're gonna need this point A, which is AA, because point E is a midpoint of AC, right? Sorry, and point A is 4 4. So now I'm gonna say since what point E is midpoint of AC, right? We're gonna have this. We're gonna have x value of E is gonna be x value of C plus x value of A divided by 2, right? So x value of E, what is it? It's minus 2, right? X value of C, we don't know. X value of A is 4, right? Yeah, but we multiply by 2 all over, we have minus 4, we have x plus 4, right? So you realize that you're going to have minus 4, which is minus 8, which is x, right? Let's leave it. That's for x. And then as for y, we'll say ye equals to yc plus ya divided by 2. Substitution, negative 1 over 2 equals to yc, do we know it? Nope. So it's y plus 4 divided by 2. We multiply by 2 all over, you have minus 1 y plus 4, right? And therefore you're going to have minus 1 minus 4, which is minus 5, which is y, right? So therefore you would conclude to say point C is what? The coordinates of C is, what did I just say here? Oh, x, yes. The coordinates here, it's going to be minus 8, minus 5. Doesn't make sense. Minus 8 and minus 5. Let's go back. It does make sense. So here, x value, it's minus 8. Here we have minus 6. It makes sense that we have minus 8 here. And this one will be minus 5. Yeah. Cool. So we're on another question now. They say given the points P, Q, RS and determine the value of X if PQ and RS are perpendicular. Alright, so definitely here we do need some space. And the question is, what will I do about that? Alright. Cool stuff. So I hope I've created enough space. Yeah. Okay, maybe let me do this. Cool. So to work this out, they told us that the two lines are perpendicular. So I will just start by saying that MPQ multiplied by MRS equals to -1. That's the equation I'm going to use, and then I'm going to just go down like that until I find the coordinates, right? Yes. Oh, at least I'm just looking for X value. So the gradient of PQ, it's going to be changing Y. Of course, we have say 4 minus 3 divided by 1 minus 2, right? Then we have multiplied by, here I'm skipping steps, of course, then I would have to write the formula, but after you've written the formula, this is what you'd have, right? Y minus y1 minus y2, x1 minus x2, right? Basically, then here I will say I have 4 minus 1 divided by x, oh yes, x minus 4, right? Just for okay, let me say equals to -1. For verification, I will go again. 4 minus 3, 1 minus 2. And then 4 minus 1, x minus 4. So everything is fine. -1, this is 1. This is, sorry for that. This is 1, then of course you have a plus here, so that is 3. Then you have multiply by, that is going to be 3 divided by x plus 4, right? And you realize that this 3 will divide this 3 because we are multiplying. Cool stuff. And now let's multiply everything we have here by x plus 4. Once we have done that, we are going to get 1 equals to -x, -4. Right? We transpose x, therefore x equals to -4. Right? And if we do that, we already from here, from this workout, we can tell the gradient of, let me remove this. We can tell the gradient of PQ. This is the gradient of PQ. As for the gradient of RS, it will be something like this. You have 4 minus 1, and then you have -4. Wait. -4 doesn't, no. Yeah, forgive me. This, we transpose it to the side, so we have this goes that side. We have -4, then we have -4 minus 1, which is -5. So yeah, plus 4, right? We are getting -3, and then that -3 you multiply it with 1/3, you get -1. So yeah, guys, yeah, just be careful. Yeah, be careful. That's just one stupid mistake in my mind. When I did that, I was like, oh, multiplication, but then you wonder, like, where is multiplication coming in here? So just be careful not to make any silly mistakes. Let's move on. So with what we have here, let's see in the diagram. C, where is C? Here is C. C is on the y-axis, right? Such that you have A is 4. Nice. Oof. I'm already seeing possible questions here. They could actually ask, so I'm already seeing this could be a parallelogram because opposite sides are parallel, so, and it's a quadrilateral, so this will likely be, yeah, it is a parallelogram. Oh, they even did say that it is a parallelogram, and then they say we have a point here, right? We could, with these 2 points, we might find the midpoint, and then with that midpoint use it to find C. I don't know, let's see. Because even C, they didn't tell us what the coordinates of C are, so you see, so that it's a parallelogram. K, here's K, it's also parallel to L and D. Okay, K, not K, here's a K is a point, and then L is a point on AB, such that KL is parallel to CD, which is also parallel to DA. They say calculate the length of DB. Here is DB, né? So I'll just do it right here. So distance, so the distance for the DB, right, it's square root of YD minus YB squared plus XD minus XB. Substitution, YD, that is 2, YB, that is minus 4. Yeah, well. XD, that is minus 4, and then we have 4. We can hit the calculator. So you have 2 minus, I'll just say plus 4, because minus will make it 4, so that's squared. Plus minus 4 minus minus 4 squared, right? And the distance is 10 upon. So let me see, it's 65 and then 6. No, this is not 65. And this is 8. It's 64 and then 36. Yeah, it makes sense. 100. Yeah, so the distance here, it's 10, right? Didn't say the units, so we'll just leave it. Determine the coordinates of M, the midpoint of DB. You guys, I told you they will say determine the midpoint, and then after midpoint, calculate. Okay, we're finding a gradient of AD. I'm sure the next question, let me see, but okay, we'll get to it. Yeah, with reason, right? The coordinates of C, right? You see it. Yeah, so we find the midpoint of DB. So you know that midpoint of DB, x, y, you have x1 plus x2 divided by 2, y1 plus y2 divided by 2, close brackets, substitution, x, so it's dB, so x is minus 4b plus 4 divided by 2, you have 2 minus 4 divided by 2, and the value you're gonna get is 0 and negative. This is negative 2 and this is negative 1. So here M is 0 and negative 1, so it's gonna be somewhere here, somewhere here, right? And then we find the gradient of AD now. AD. Yeah, we find the gradient of AD. Gradient of AD is equals to YA minus YD XA minus XD substitution. A, y, that is 4 minus D, which is 2, and then X for A, that is 0, 0, 0 minus 4. 0 minus 4. Yeah, so you see this is an increasing function. On the straight line itself is increasing. So you already have an idea to say, this will most probably be, it's a must. It's not a most probably, we must get a positive gradient. So you have 4 minus 2, which is 2 divided by 4, which is 1 over 2. That is a gradient for, yeah. Let's see what we have next. So we have the gradient of AD, which is 1 over 2. We have the midpoint here, which is 0 and minus 1. Now we're going to prove. They say prove that AD, this is AD, right? So we're proving that AD and AB are actually perpendicular. So the thing is, we have the gradient of AD. We must find the gradient of this one, AB. So let me see if we did actually find the gradients. We never did. So let's get right on it. So for AB, you would say AB, it has to give you, of course, YA minus YB. How's it go? XA minus XB, substitution, that is 4 minus 4, that is 0 minus 4. Alright, so here you're gonna have that's a positive, right? So that is 4 plus 4, which is 8, divided by, here you're getting minus 4, which is minus 2, right? So you would say gradient of AD multiplied by gradient of AB, then equals to, you have 1 over 2 multiplied by negative 2, which is negative 1, and therefore AD is perpendicular to AB. Right, we're getting closer. And then they say give a reason why this is a rectangle. Right, as for now, why this is a rectangle, you already know. Opposite sides are parallel, right? And then the corner angles, right? Since this gentleman here, since DA and AB, they are perpendicular, they give you a 90 degrees. So from that, you're seeing that, interior angles will be 90 degrees, because also these two lines are parallel lines, né? So this angle plus this angle, they have to give you 180 degrees. So we have 90 here, therefore we have 90 here. We have 90 here, therefore we have 90 here, and therefore we have 90 there. So any of the reasons, I would say here it's really important to know the properties of a rectangle, and then determine the equations of KL, right? So KL is parallel to DA, so you know that y equals to mx plus c. The gradient, you're going to use the gradient of DA, which is what? Which is 1 over 2. So you have x c plus c. And then we're going to use this point, right? 0 minus 2, 1 over 4. We're going to use that point to substitute it. So what is x? X is what? X is 0. So here you're going to have x times this, it's going to be 0 plus c, right? And then y is going to be minus 2 plus, minus 2, 1 over 4, right? Which then therefore c equals to minus 2 1 over 4. Right. After that, we get to the end that says write down the with reasons the coordinates of c. Right, coordinates of c. So coordinate of c, like I said, remember there was a question that asked us to find the midpoint of db. Right, we found that midpoint. Let me check. It was, oh, the midpoint, it was 0 minus 1. So the midpoint was 0 minus 1. And now that we have the midpoint, it becomes easier. We can use that midpoint to find point C, because what's happening is, remember the diagonals of a rectangle, right, where they meet, that point where they meet, that's the midpoint of each diagonal, right? So you will say, for example, midpoint value of x a plus xc divided by 2. For x we had 0, and then therefore you have xa, which is 0, plus, what am I doing here? Yeah, divided by 2. And then from this, it's clear, you'll multiply by 2 all over, and therefore x is gonna be 0. Right, for y, y c, no, yes, we had minus 1 here, and therefore this is gonna be 4 plus yc. 2 will multiply by 2. You have minus 2 equals to 4 plus yc, and then you have minus 2 minus 4 yc equals to minus 6, right? And therefore coordinates of c is what? It's 0 and negative 6, which makes sense, right? So yeah guys, yeah, so this is it, and it's the end of analytical geometry. I'll see you in other chapters. All right.